Aeronautical A. I'm going to say about a flow of a fluid. This is a great scientist called Reynolds. He given a number which is used to define a fluid flow, the fluid patterns in a different fluid flow situations. So he said a Reynolds number as the ratio of inertial forces to the viscous forces. So the Reynolds number helps to predict the flow patterns in different fluid flow situations. At lower Reynolds numbers, the flow is tend to be dominated by laminar flow, and at higher Reynolds numbers, the flow is tend to be turbulent in nature. So according to Reynolds, the flow is classified into two types, namely laminar flow and a turbulent flow. So on upon going to laminar flow, so laminar flow, upon seeing this diagram, we can say that the velocity of the fluid at a point is constant on time being. So in laminar flows, the fluid slide in parallel, and there are no eddies, with no eddies, swirls, and current normal to its flow itself. This type of flow is also referred to be as a streamline flow, and also it is called a laminar flow at present. So watch over this. This is a valve pouring out a water of 20 k 20k liter per second. This is a huge quantity of water pouring out, and we can observe this a line of flow of water is a laminar in nature, but it possesses some light turbulence in nature, but mainly it is defined as a laminar flow because its Reynolds number is approximately greater than just nearly greater than 2000. Just it is near to 2000, so it acts as a laminar flow at most. Uh, it's a huge, big example in a real life, which is dangerous and real example. And we can say a flow of check dams. Uh, like a check dam flow is also a laminar flow, which is constant in nature with velocity of water at any point in the flow at any time. A turbulent flow, we can see that the speed of the fluid is continuously changing with respect to time. So the turbulent flow, the speed of fluid at a point is continuously undergoing changes in which magnitude and direction. The flow of winds and rivers is generally turbulent in this sense. Even if the currents are gentle, the water, the air, squirrels and eddies, while its overall bulk moves along a specific direction, is known as a turbulent flow. It says that the fluid at a point, at any point in a fluid, the velocity of the fluid changes along its direction or its magnitude. So this nature in the flow is known as the turbulent flow. And watch out this. This is fluid is coming from this, and this is going to be turbulent in nature, and it is going in one direction, but it has across it is facing eddies, squares, and many more. And you can observe the velocity is not constant uh, across this, but until a point, it's a laminar flow, and thereafter it is undergoing to a turbulent flow. We can understand about this by seeing this clip, uh, and this is a real life example every student can get, or every person who have a kitchen in their home can know this laminar flow and turbulent flow easily. So consider a kitchen where we have a sink and a tap which is going to give a flow of water. So on the tap, we'll be seeing a flow like this, in the laminar flow, which is going to fall into that cap at present. That is a laminar flow. It will be having a velocity at any point in the flow of water is constant. I mean, the velocity doesn't change upon time being. Uh, so that is known as a laminar flow. And see, bottom after the cap spills the water, uh, it becomes a turbulent because of water goes in different directions. Uh, the direction has been changed of the water and it undergoes some eddies, some squirrels, and it doesn't come to a laminar flow, and it is crumbled. This flow is known as turbulent flow. So this is the difference between the laminar and turbulent flow. So let us go through the applications of the laminar flow and the turbulent flow right now. Uh, Upon going to that, a biggest thing we have to know that is known as the Reynolds number. Reynolds number, which is going to help us in predicting the flow patterns. So Reynolds number helps in predicting the flow of patterns in different flow situations. At low Reynolds number, the flow is tend to be dominated by laminar, while at high Reynolds number, the flow is tend to be turbulent. Upon saying by Reynolds, he said that the ratio of inertial forces to the viscous forces is known as the Reynolds number. The Reynolds number is on simplified formula. We have this is as a rho BD by mu, where rho is the density of the fluid, velocity of the fluid V, D is the diameter of the pipe or the diameter of the object which we are going to consider the fluid flow, and mu is the dynamic viscosity of the fluid, and Re the relate the needed number, the dimensionless number, that is the Reynolds number. See the applications of the flow, laminar and the turbulent flow. So laminar flow is in normal conditions of a blood flow through most circulatory system. Is a normal condition of the blood flow. We can see in our body the blood flows continuously, and that flow is known as a laminar flow because it cannot be a turbulent. If it is a turbulent, our blood doesn't have proper regulations in the flow. Uh, and it is considered as a laminar flow because the flow of the flow throughout the nerve is constant. The velocity of the blood at any point in the nerve is constant upon time being. So that is known as a laminar flow, and it is a well-defined streak line flow. It's a well-defined streak line flow for a laminar flow in bodies. And we can say any fluid which is having less than 2000 the laminar flow. Reynolds number which is less than 2000 is laminar flow. A turbulent flow. Generally in our bodies, blood flows in laminar nature. However, upon going to aorta, upon going towards the heart, the blood going into the heart and away from the heart, pumping away from the heart. This process at aorta, all blood under conditions of high flow, particularly in ascending aorta, laminar flow can be disrupted and become turbulent. At aorta, near to the heart, upon the blood reaching the heart, the blood undergoes into a turbulent nature from laminar nature because of the high flow. Under conditions of a high flow, the high flow occurs at the aorta from different veins. It's an irregular strike line. it's an irregular straight line. We can say any fluid which is turbulent in nature by Reynolds number, which is greater than 4,000. And did you notice what happens to the Reynolds number, which is greater than 2,000 and lesser than 4,000? Yeah, the Reynolds number, which is greater than 2,000 and lesser than 4,000, are said to be a mixture of uh, few laminar flow and turbulent flow, which is also defined as a transitional flow, where there are different types of flows which are occurring together. That is laminar and turbulent flow. So this is what about the flow according to Reynolds and Reynolds number. So this is what the two types of flow, laminar and turbulent flow. There are many applications as laminar flow and turbulent flow. So we can use laminar flow in different situations and different things.